Hey, look, I think we'll get started. Welcome, and thank you for coming to the session this afternoon. There are always heaps of really interesting sessions on at Ignite, and personally, I find it really hard to sort of choose the sessions I'm going to go and visit. So I really appreciate you coming to this session this afternoon. We won't turn on the laser pointer. So my name's Daniel Bobias. I'm Innovation Lead for Datacom's cloud teams down in Wellington. I also help run the infrastructure and Azure user group down in Wellington. So if you're at my last session, this will be a bit of a repeat. If you enjoy beers and pizzas and you want to learn more about Azure, please join our meetup, and we'd love to see you at the next session and say hi. So this is the North American Eagle. It's a jet car. I like jet cars. Microsoft is sponsoring the team of the North American Eagle in their attempt to break the land speed record this year. Now, to do this, they're going to need to travel over 1,228 kilometers an hour across a salt plain, which I think is pretty cool. Designing for speed and performance, it's all about understanding and working with limits. And in just the same way as the crew of the North American Eagle, they know the limits of every single one of the components and systems that go into their jet car, then we too need to understand the limits of the Azure services that we're looking at using. And it's not just about knowing the limits and the performance targets, but it's what happens when we try and exceed those limits. That's where the really interesting issues occur. So this session, we're focused on Azure Compute and Storage and how to design solutions using Azure Compute and Storage which optimize for both cost and performance. I'm interested to sort of find out how many people in the audience are actually currently using Azure Compute and Storage in your day job. Cool, quite a few of you. How many of you are using other Azure services? It's getting pretty hard to keep up now, isn't it, really? It took me ages to take all of the different copies of every single icon and animate that slide. I wanted to put that up, though, because it kind of puts it into perspective a little bit. That, in this session, we're just talking about two of those boxes. But what I'd put to you is, and you would have seen with the hands that came up, these are pretty fundamental foundation items that a lot of customers use to build their solutions in Azure. And it's not just customers. Most of Microsoft's higher-level services that we saw on that previous slide are based on Azure Compute and Storage. So it's seen it's really critical by Microsoft as well. Now, as I mentioned to a couple of you when I was out in the audience, we're going to be talking about, this is a 300-level session, right? We're going to be talking about performance targets and limits, how we can architect around those limits. But before I dive in and just start sort of throwing numbers at you, left, right, and center, I want to kind of cover off a couple of high-level concepts. I want to take us through a bit of a tour through compute and storage. Then we're going to dive into a whole lot of numbers. And hang in there, because we're going to pull it back together again with some examples and some fun stuff towards the end. So, I want to talk about scaling. When we want to increase the capacity or performance of an item, we generally have two choices. We can scale it up. We can make the thing bigger. Or we can introduce multiple instances of an item. We can scale it out to remove the bottleneck that way. And now, a lot of times when people think about the public cloud, they think about scaling out. And there are lots of really awesome examples of parallel computing workloads which are scaled across multiple hyperscale clouds like Azure. And they work really well, and it's awesome. But scaling also has costs associated with it. And what we're going to see in this session later on is that scaling out is sometimes not the most cost-optimal way to address a bottleneck. The other thing we need to talk about is IOPS and throughput. Now, we're talking about storage, so unfortunately we're going to talk about some storage terms. So, when we talk about storage transactions, we talk about IOPS, input-output operations per second. But that number by itself is kind of meaningless unless we know the average size of our I/O. Now, the reason we need to understand this, and the reason it's really critical to us, is in Azure, all of our storage is network attached. So we need to ensure that our virtual machine has enough network capacity to support the storage traffic that we're going to generate. So it's not just the amount of network traffic our application generates, it's also the network traffic that our storage transactions generate. And those storage transactions count towards the network allocation that's given to us for our virtual machine. Okay, to do this, it's a pretty simple calculation, right? We take our IOPS, we times it by our I/O size, and we get what we call throughput. Let's go through an example. If I've got a workload that needs 5,000 IOPS, it's going to generate 5,000 IOPS, and that I/O is going to be 8 KB. Divide by 1024 to make it a bit easier to read. I'm going to generate 39 meg a second of network throughput, of network traffic. So my application is going to add 39 meg worth of traffic onto my network. So I need to make sure that my virtual machine has enough capacity for that storage traffic, plus the traffic that my application is going to generate that storage traffic. All right, let's talk about compute. So I just want you to hold that storage stuff in your mind as we're going through. Now, I know there have been a couple of sessions on compute already, but I just want to kind of cover off to make sure we're all on the same page here. Microsoft designate VM types into series, or sometimes they're called families, and then inside those families we have instances, and instances are designated by a number. And Microsoft have been steadily introducing new hardware into their data centers over the last couple of years. And every time they introduce new hardware, we get these new virtual machine series that can take advantage of that hardware. And they've been busy. And it's starting to get a little bit like alphabet soup. So, generally, as we move up through the series, we get faster CPUs, we get bigger virtual machines. Starting with the A series, these are really economical virtual machines. They're great for dev test, okay? There's a basic version of the A series. That's even more economical still, but Microsoft limits what these virtual machines can be used for. So you have to be a bit careful. We can't attach them to auto-scaling groups, for instance. There's some arbitrary performance limits applied to those virtual machines that we'll talk about. The D series. Now, this is really good for production workloads, and there are a couple of variants of the D series virtual machines. The V2 series, V2 variant, which has just been out for about a year now, that's based on 2.4 gig Haswell processors. And interestingly, it's actually cheaper than the original V1 variant. Obviously, that newer hardware is a bit cheaper, and Microsoft have passed that on to us. F series, these are really good for workloads that need more CPU than memory. They run on the same hardware as the D series. G series used to be what Microsoft called the Godzilla series of virtual machines. They were the biggest virtual machines. They still actually are the biggest virtual machines you can deploy. And they're targeted for workloads like SAP or HANA workloads, really large SQL servers, Hadoop, DataZen. And just to make it interesting for speakers to have to redo their slides, Microsoft announced the H series of virtual machines 2 or 3 weeks ago. The H series are run on hardware which is designed for high-performance computing, and and it's designed for financial risk modeling and genomic research. Now, this series is really new, and the hardware's only been released in 1 or 2 data centers. So it's quite hard to get your hands on those series at the moment. The other thing to note is that these S variant virtual machines, okay? The S indicates an instance which is deployed onto hardware which has local SSD drives attached to it, okay? Now, those local SSD drives are required by premium storage. So we can only attach premium storage to S variant virtual machine instances. And we'll look at that in a bit more detail shortly. So, as you can see, Moore's law still stands, and as new hardware is made, Microsoft are releasing it into the Azure data centers and enabling us access to it with these different series of virtual machines. The trick for us is to ensure we're using the right series of virtual machine for our needs. Now, while we can change between these different series of virtual machines, there are some limitations that are imposed upon us by the physical infrastructure. And this is where things start getting interesting. So when Microsoft build data centers, okay, they add hardware in what they call scale units. Now, they're sometimes called compute clusters. I like to think of a scale unit as a container. And Microsoft used to do containerized data centers, but essentially when Microsoft deliver new hardware into the Azure data centers, 30 trucks turn up with containers on them, drop the containers off, plug it in, Bob's your uncle, away to go. Why do we care about this? When we deploy a virtual machine, it gets deployed to a scale unit. The capability of that scale unit dictates the options that are available to us in resizing our virtual machine. So there are currently 6 or so different types of scale unit. And as you can see, there's an overlap between the different virtual machines that scale units can support. So what we're talking about here is our ability to be able to resize our virtual machine instead of destroying our virtual machine and recreating it. Now, a good way to see this, if we actually jump into the portal and have a look. Push the right button. So, everybody's familiar with the new Azure portal, right? Yep, I'm going to take the few nods I got. It's late in the afternoon. So, I've got here a A1 basic virtual machine. And if I click down to my sizing options, and everything going well, this pops up. When this pops up, it's going to show me all of the different instance types that I can resize this virtual machine to. He says, fingers crossed. Oh, look at that, there we go. Okay. I can do the same thing via PowerShell, but obviously I don't get the nice UI giving me the options. So if I scroll down, I can resize this running virtual machine, and it will shut it down and bring it back up to a D series, V2 only. An F series, runs on the same hardware, obviously. Or an A series. But I don't get any premium storage options here. There's no S variants, and there's no G series virtual machines. So I'm deployed into a scale unit, I think it's about a 4 or a 5, and I've got quite a range that I can resize it to, but I don't get access to all of the different series available. If I click on this virtual machine here, now this virtual machine I've powered down, because when I go to do a resize on this, because I'm not sitting inside a scale unit, I don't have those same limitations applied. So I get my S variant virtual machines available to me. I get my V1s available to me. And if I scroll all the way down, I get my G-series virtual machines available as well. So some of you may have come across this when you've gone to resize a virtual machine, especially via PowerShell, and it's come back and gone, yeah, nah, that's not going to happen. All right? The scale unit you're on has that impact as to what our resizing options are. So we want to be careful about how we approach deploying virtual machines, especially if we're going to be scaling them up and down. Because when you're first starting out, right, you're really cost conscious. Well, most of us are. And you deploy your virtual machine as a really small virtual machine. I've got a couple of customers that have done this. They deploy it as an A0 basic virtual machine. It's the most cost-efficient one to run. And then they've gone to scale it up as their applications come under load, and they've gone, oh, I can't scale it past an A4 basic virtual machine. I'm going to have to destroy it. I'm going to have to remove all of my linkages to my load balancers. I'm going to have to recreate everything. This is a real problem, Daniel. So one approach to get around this is to deploy your virtual machines at the largest size that you think you'll require, and then perform a resizing operation to resize that virtual machine down to your sort of standard runtime or your even precursor to that. That way, we ensure that we're allocated into a scale unit that has the capacity when we're going to need it. And okay, we might not quite get the same cost savings. Like if we think we're going to need a GS5 virtual machine and an extension on our credit card, we're only going to be able to scale that back to a GS1 virtual machine, right? But at least we'll be in a scale unit that can support our workload under pressure. So it's about understanding that physical infrastructure and how that kind of echoes up into that virtual space and affects some of the operations that we have. Right. I've got a link here. You can go and check out all of those different sizes if you want. And those slides will be available online as well. But I think we've got a handle on the sort of the high-level compute. I want to jump into storage now. So the first thing we need to be aware of with storage is we can have multiple storage accounts per subscription. And we don't pay for a storage account. We pay for what we do with the storage account, but not for the storage account itself. When we create a storage account, we get access to what Microsoft call blobs, tables, and queues. But it's blobs that we're interested in for this session, specifically page blobs, because it's page blobs that provide us with data disks that we attach to our virtual machines. And that's the focus of this session. When we create a storage account, we need to select a performance, the performance of the storage account that we require. We get the choice between cool, standard, and premium. Cool storage doesn't support page blobs, so we can't use that for our virtual machines. So that leaves us with standard and premium. Standard storage uses magnetic rotating media. What does that mean? It's spinning disks, right? And we're billed based on the actual data we write to standard storage. So I can allocate 100 gigs of storage to my virtual machine, but if I only write 1 gig of data to that storage, then I only pay for the cost of storing 1 gig of data. It's pretty cool. Makes life easy, right? Premium storage, that uses SSDs. It's heaps faster, really low latency, and really awesome network throughput. But we pay for what we allocate, not what we use. So if I allocate 100 gigs worth of premium storage to my virtual machine, I will pay for 100 gigs worth of premium storage per month. And again, it's something that just catches people out, and then they go, well, hey, my costs are a whole heap more than I expected. Yeah, because you pay for what you allocate versus we pay for what we use. Now, premium storage. As we said, premium storage uses those local SSDs, which are attached to the hardware that our virtual machines are running on. And what premium storage provides is it uses those local SSDs as a read cache. And we can turn it off if we want, but it's a read cache, not a read-write cache, so it's a safe cache. With that read cache enabled, drops our disk latency down from around about 5 milliseconds down to less than 1 millisecond. And I'm going to show you that in a demo that I've got running. So less than 1 millisecond disk latency is pretty awesome. Compare it to standard storage. Standard storage, the latency's around 10 to 15 milliseconds. So it's quite a lot slower. The other cool thing about the read cache is if we're reading our data out of our read cache and it's coming from our local SSDs, then we're not using our network. So it's not impacting our network capacity to access that. So read cache it's good. The next option we have when setting up a storage account is we need to choose the resiliency that we require. Okay. At a minimum, our data is written to 3 different locations within an Azure data center. This is called locally redundant storage. And it's like having a 3-disk mirror set. I'm going to come back to that. I want you to keep that in your mind, okay? It's just like having a mirror of 3 disks. Currently, premium storage only supports LRS. So it's the only option we can choose for premium storage. For standard storage, standard blob storage, we can select GRS as well, globally redundant storage. So with GRS, 3 copies of our data are written to our local data center, and then 3 copies of our data are written to the data center that's paired with our data center. So you would have noticed when Microsoft sort of announces data centers, it's always in multiples of, or at least 2. There always tends to be 2 data centers in a geopolitical region. That's to enable GRS. So in Australia, if we've got our storage account in Australia East, and we choose GRS, then our data will also be written to Australia Southeast as well. Okay, so we can have multiple storage accounts in a subscription. For page blobs, these can be premium storage or standard storage. And we can choose for our data to be written to 3 or more locations across those data centers. But we haven't really started digging into those limits and the performance targets. So let's take a deep breath and work our way from the top down. The first set of limits we need to be aware of sit all the way at the top at an Azure subscription level. Now, for a lot of organizations, you're never going to hit these limits, but I think it's really important to understand that they do exist. And if you're working on a project that, say, is going to need more than 250 storage accounts, then you're going to have to consider scaling out across multiple subscriptions. These are hard limits, by the way. There are a whole lot of soft limits that you'll hit before then, and it's a phone call to Microsoft, and they'll increase those limits for you. But you can't go past these limits. So we can scale up to 250 storage accounts inside a subscription. Then we have to scale out across multiple subscriptions. And we need to make sure our application can support that, because there's different keys we need and a whole lot of stuff. It gets quite complex. But more interesting, let's talk about the performance targets and limits associated with VMs. So I've got the basic tier A series virtual machine on the screen there, okay? And as we move up through those different instance types, we get more cores and we get additional memory onto that virtual machine. But also the number of data disks that we can attach increases. The number of NICs that we can attach. And our network bandwidth allowance. Now, big thing to note with basic series virtual machines. They are limited to 300 IOPS per data disk. That's a limitation Microsoft imposes to get the price down. There's a reason these machines are really cost effective. The other thing we need to note is the limit around our data disk size, okay? Currently in Azure, data disks are limited to 1024 GBs in size. It's a hard limit. It's a storage limit. We can't go past that. So if we need to access more than 1024 GB of storage on our virtual machine, we need to add more data disks to our virtual machine. And we'll talk a little bit shortly about some things we can do around that. We move to our standard A series. Pretty much most things stay the same, but our disk IOPS increases to 500 IOPS per disk. We're no longer being limited by our virtual machine instance. We're now hitting a storage subsystem limit. So we need to understand where these different limits exist so we understand where the bottleneck might be. Now, the other thing we get with, once we get into the standard series is our temp disk allocation starts increasing quite significantly. And I'm going to cover off temp disks a little bit later because they can be really important for some applications and have a big impact on our I/O requirements that we have. D series, very similar again. More CPU cores, more memory. Number of disks we're going to attach increases. Notice our IOPS hasn't changed. Storage limitation now, not a virtual machine limitation. Number of network adapters that we can attach increases. Network bandwidth. Right? It's not until we start looking at our S-variant virtual machines that things start looking a bit interesting. With S-variant virtual machines, our IOPS performance target and our limits are specified as per virtual machine, not per disk. So if I look at that DS1 virtual machine, I can have 2 data disks attached, and I should get around 4,000 IOPS. That's my performance target. Okay? So I could be driving 3,800 IOPS out of one data disk and 200 IOPS out of the other data disk, or 2,000 IOPS out of each, or 4,000 IOPS out of one. But it's up to me to make sure that I'm not trying to exceed the performance envelope which is allowed for this instance of virtual machine. And those of you that remembered that IOPS calculation, the throughput calculation I put at the start, you'll notice that, hold on, 4,000 IOPS times 256 KB divided by 1024, that's a lot more than 32 megs worth of network throughput. Okay? So some of these numbers that Microsoft give us are based on read caching being enabled, and therefore a reduction in our network bandwidth. But we also need to be careful with that, because if we've got an application which is doing lots of writes, well, the read cache isn't going to help us very much. So we need to make sure that it's not just we've got enough IOPS in that envelope, that we've actually got enough network throughput available to us to drive those IOPS as well. GS series, essentially getting the theme here, right? I'm not going to go through them all. I like the GS5 though, because we can have 64 data disks attached to that, and we get 80,000 IOPS worth of throughput. And the air points are fantastic when you're paying for it on your credit card, right? Just out of interest, you know, these GS5 series virtual machines are so big that Microsoft actually allocate you the whole physical server. So when you request one, they give you the whole server and go, there you go, fill your boots. These things do change. I've had to update my deck about 4 times in the last couple of months, so it pays to check back on these limits. Hence, I've got these URLs through the deck, so you can look back and have a look and sort of just double check on these things. Well, what I want you to remember out of this section is it's not just about how many CPUs that you have and how much memory. We also need to consider the amount of temp space that's made available to us, the number of data disks that we're going to need to attach and can attach, the network throughput that we require and that we have available, and the number of network interfaces we want to attach as well. Okay, there's quite a lot of different variables that we need to consider here to get that optimal fit. And it's not just virtual machines that we need to worry about. Okay, so our storage accounts also have limits and performance targets. Standard storage account can support 20,000 IOPS. If we try to drive more than that, we get rate limited. Rate limiting is bad. It's really hard to diagnose too. I'll tell you how to set some alerts on that. So we can have multiple data disks within a storage account, and we can have those data disks attached to virtual machines. So we have lots of different virtual machines accessing that one storage account, but we can't exceed 20,000 IOPS out of that storage account. And roughly we get about 20 gigabits per second worth of network throughput out of a storage account. Premium storage, well, that's different again. We're not limited by our IOPS with premium storage. Okay, it's the way SSDs work, it's all a bit different. We're limited by the total capacity we can provision out of that storage account. So again, we can have multiple disks that we create inside that storage account, but we can't provision more than 35 terabytes worth of space, worth of capacity. If we do, we get throttled. If we want to exceed these limits, we need to scale out across multiple storage accounts. Okay? We can scale up to 35 terabytes, then we need to scale out. And we need to make sure our application can support that. And hang in there, because this is the last slide, and then we're going to go through some examples, all right? Disks have limits as well. We talked about that a standard disk can be a maximum of 1024 GB in size. We get 500 IOPS. Now that's a performance target, by the way, and a limit. Doesn't mean we're going to get 500 IOPS. It's what Microsoft hopes to give us. We're going to talk a bit about how we can check to see what the real world performance is that we're getting. But if we've got an application that needs to access more than 1024 GB of data, and we want to present it to that application as a single disk, what we can do is we can attach multiple data disks to our virtual machine, and then we make a stripe across those. Or we use storage spaces, or the Linux equivalent. I used to know what it was. A logical volume, I think. But before you kind of go, well, hold on a minute, striping's really bad, there's no resiliency, what's he talking about? Remember I said, in Azure, when we write data, we're writing it to 3 different places. So it's more like a mirror than actually a single disk. So when we're creating a stripe of these data disks across in our virtual machine, it's more like a RAID 10. We're striping that data across multiple mirrors. So we don't have the same resiliency issues that we might have if I got 3 dodgy disks and created a stripe on premise. Premium disks, well, I think you know what I'm going to say. They're different again, right? We get 3 different sizes of premium disk. Tops out at 1024 GB, just the same as a standard disk does. Okay? But I can provision any sized premium disk up to 1024 GB, but I'll be billed at one of these 3 levels. And the performance that I will receive will be based on one of these 3 levels. So if I allocate 50 gigs of storage to a virtual machine, premium storage, I'll be billed at the P10 price. All right? I'll get 500 IOPS, and I'll get 100 meg per second worth of network throughput to that. And I can scale my premium disks up whenever I want. And as I scale them up, I pay more, and I get more performance. Now, there's a reason that Microsoft allows us to do this, because I can see you all going, why would I allocate 50 gigs? I'm paying for 120, I'm going to allocate that, right? If you're getting close to that 35 terabyte limit on your premium storage account, and you've got a P20, and you just need another 100 gigs, right? But you don't have enough capacity to expand that out to a P30, then you'd have to create a whole new storage account, and you'd have to migrate that disk or create another disk and attach that. It's a bit of a pain. So Microsoft have gone, well, we'll give you the flexibility that you can expand that disk out by 100, by 100 gig, and you're still going to pay for the P30, but at least you're not going to have to create a whole new storage account and attach another data disk. It gives you that flexibility. But just be aware, if you create these 513 gig disks, you are going to pay for 1024 GB worth of storage. Okay, so we've made it through all the numbers, right? So we need to ensure that the VM that we select can support the number of disks that we're planning on attaching, the IOPS that we're going to generate, and the network throughput associated with that. We need to ensure that the storage account that we store those disks in has enough spare capacity to support that I/O. And then we need to have understood the performance limits associated with the disks we're using as well. So we've got all these different layers that we need to bring together to make work. Check out the storage limits and the scalability target URLs. There's some more information in there. And again, the stuff changes all the time, so check back on that. But let's take all those different numbers and limits and performance targets and then work through an example or two to kind of bring it together and make it a bit real. So let's say I've got a workload and my vendor says, look, you're going to generate around 10,000 IOPS, and we've tuned this so that it's going to be 8 KB I/O. I know that's kind of deep storage stuff, so just kind of hang in there. So we do our little calculation, and we go 10,000 times 8 divided by 1024. So I'm going to generate around 78 megs worth of network throughput. So I've got the key things that I need. Well, standard storage is the cheapest, right? So we're always going to do it the cheapest way. Let's use standard storage. So I'm going to need 20 standard disks. This is my scaling out model to hopefully get that 10,000 IOPS. Remember, these are performance targets, not guaranteed. So I need to make sure the storage account that I choose has 10,000 IOPS available in it. It needs to be 50% free. What's the virtual machine that I'm going to need for that? So let's just look at the D series. So 20 data disks. So I'm going to need a D14 virtual machine. Supports 32, sweet. Bit of capacity to spare, we like that. So we'll add that D14 virtual machine in there. Now let's say that we're going to write 2048 gigs of data. And that capacity is important. We'll come to that in a minute. So that's going to cost me about 244 New Zealand dollars a month. I kind of checked these figures last week, so they're accurate for probably the next 3 minutes, and then they'll change, all right? But just, it's all baselined. That virtual machine, that's a kick-ass virtual machine, right? That's going to cost me $2,700 a month to run. So it's going to be near on $3,000. Okay, my storage is cheap as. That's awesome. But I need a really big virtual machine to be able to attach it to. What if I use premium storage? Well, I'll need 2 disks, right? 2 P30s, that'll give me my 10,000 IOPS, and super low latency as well. Need to make sure my storage account has 2 terabytes worth of capacity. Yes, probably be sweet as. Now, I'm going to need an S variant virtual machine, okay? We'll stick with the D series. So 2 data disks. I could use a DS1 not, because that only gives me 4,000 IOPS. Remember, 10,000 IOPS. So I'm going to need a DS3 virtual machine. Gives me my IOPS, and it gives me my network throughput. So let's plug that into the calculation. So if almost by magic, it just so happens that those 2 P30s will give me 2048 gigs of capacity, and that's going to cost me $400. So it's going to be a bit more expensive for my storage, right? But my virtual machine's a whole heap cheaper. It's actually a third of the cost. So by scaling up my storage rather than scaling out my storage, I can have a smaller virtual machine and I reduce my cost. So part of this is about understanding what the cost implication of the up and the downstream systems are that I'm integrating with, and how scaling options that I'm choosing at one level affects things above and below me, or left and right of me, depending on how you like to think about it, in that chain. I want to go through one more and then talk about some of the things that can catch you out. Okay, so 2,000 IOPS this time, 8 KB. Calculation, we're going to need 15 megs worth of network throughput. Standard disks, far less this time. We're only going to need 4, right? That'll fit into a standard storage account. And a D2 virtual machine will work for us. Let's say it's only 512 gigs of data this time. $430 a month. The air points aren't anywhere near as good as that. Premium storage. Let's do the same again. Single disk this time, right? I can use a P20. It's going to give me 2,300 IOPS, more than I need. Perfect. That'll fit into a single storage account. And I can do that with a DS1 series virtual machine. So it's going to be cheaper. But, and here's where the big buts come in. If my I/O had been higher, okay, if my vendor had said, actually, we've optimized our package so it generates 32 KB I/O rather than 8, well, that would have required 62.5 meg of network capacity. And a DS1 series virtual machine only has 32 meg of network capacity available. So I would have had to choose a DS2 instance to be able to get the network throughput that my I/O would have been generating. Now, it's going to be a little bit more expensive, but I'm still going to get that really super low latency storage, which my application may need. So I shouldn't forget about my latency either. So, as you can see, depending on your I/O requirements, and depending on the amount of data that you need to store, it can be cheaper in a number of circumstances to use premium storage over standard storage, to scale up rather than scaling out. But as our storage requirements increase, we get to this inflection point, this tipping point over time, where actually it then becomes cheaper to run a bigger virtual machine and scaling out across that standard storage than to keep on adding those really expensive premium disks into our solution. Okay? So you want to have a think about and look at when you're doing this and go, well, I'm starting off here, but how much storage do you think we're actually going to need? And at what point are we going to hit that inflection point where actually we might want to turn it around and we maybe want to go from standard to premium or premium to standard and change that virtual machine. And I've got some graphs which look super complicated where you can chart it all through, and I'm not really a statistician, but some people get really excited about that stuff and the likes. But it's really important to sort of understand your application and your workload and look at that information. And then you can choose the most optimal configuration for your scenario. All right, let's talk about something a bit less taxing. I said that these are performance targets. So we have these limits. We can't go past those limits. And Microsoft really wants to give us services which work all the way up to those limits. But then there's the real world. And the real world is always different, right? So we've got our system all set up in Azure. How do we go about actually measuring the disk performance that we're getting? What do we do to be able to ensure, I'm talking specifically about storage here, to ensure we're getting the IOPS and throughput that we need? So there's a number of tools that you can use, but one that Microsoft recommends, and it's one that I quite like, is I/O meter. It's not made by Microsoft, it's actually made by Intel, and they open sourced it. Now, I've got I/O meter running on a couple of VMs, and we're going to go and have a quick look at it. But before we do that, I need to give you a word of warning. When you run I/O meter, by default, when you point it at a disk, it tries to create a file on that disk, which it reads and writes from to do your performance monitoring. The default behavior is to create a file that uses all of the space on the disk. That causes production outages. All right? I think the change manager will forgive me at some point. So, when you're using I/O meter, by all means, have a test, have a play, but just don't phone me up when you run out of disk space on your production system and say that I've caused an outage, all right? The reason it tries to use up all of the disk space is actually that's the good science around getting that proper performance of the disk, because it wants to read and write across all the different parts of the disk to fully exercise it, because it's quicker for stuff closer to the spindle than stuff on the edge, and there's a whole science around it. Just be warned. The other thing is, I/O meter generates a whole lot of IOPS, a whole lot of I/O. So if you're running it on a production system, you're going to cause performance problems for your application, right? So that's great to use when you're setting infrastructure up, and before you go into production, you want to check to make sure that you're getting that type of performance that you expect. So let's cut across. See if I get the right button. Hey, right. I have 2 virtual machines here running in Azure. All right. There's a whole lot of science behind measuring disk performance, and you have to warm things up and speak nicely to them. And so these virtual machines have been running for the last couple of days. The caches are all full, and I/O meter's been running for the last 2 hours. Okay. So this first virtual machine, this is an A1 basic virtual machine. So this is the most cost-effective virtual machine that we can buy. Well, there's one smaller, but we've got 1 CPU, and I have down the bottom here a standard disk attached, and because I didn't want to wait 3 days for it to fill up 1024 GB of space, I've just kept the partition pretty small, okay? So it's just 10 gigs. And I've got I/O meter running here. So I'm getting, at the moment, round about 234 IOPS out of that standard disk. Remember, my limit is 300 IOPS. My performance target is 300 IOPS. I'm not doing too badly, actually. And my disk latency is actually looking really good at the moment, 4.26 milliseconds, right? It does change during the day, by the way. In the evening, I notice that my disk, for this one especially, my IOPS increases, right? So while Microsoft has partitioning, there's still some shared infrastructure that, can hit us. So that's one end of the spectrum. Let's go to the other end of the spectrum. So this is a D1 series virtual machine. You'll notice it's the same CPU as I have in my, appears as the same CPU as in my A series. A bit more memory in this one. What I've got down the bottom here is I've got 2 P10 premium disks, and I've striped across them. So each of those premium disks should be giving me 500 IOPS, and that stripe should be giving me 1,000 IOPS. But I'm getting 1,224 IOPS. This is my read cache helping me out. All right? Also, my latency is really low, 0.8 milliseconds. I showed that to my storage guys, and they're like, what? You got 0.8 milliseconds? I'm like, yeah, you should check out this one. This one's really bad. But it just shows that difference, all right, between, those smaller, limited virtual machines versus those slightly larger virtual machines, and going from the standard storage to that premium storage. Now, you can get in here and you can play with all of the different settings and random read writes and everything else, but I've got the same profile running on both to keep it nice and even. Okay? Really cool tool to have a play with and spend lots of time looking at numbers and getting to know your storage chat much better. Right. Let's flick back across. We're going for time. A couple of minutes. I want to talk about throttling. We've talked about, we have these limits everywhere, right? We have limits at a subscription, at a virtual machine, at a storage account, at a disk. Now, at a virtual machine, it can be pretty easy to see when you're hitting limits, because you can look at that virtual machine, you can look at your disk queues, you can go, oh, my disk queues are blowing up, and the I/O that I'm driving's getting up there compared to what my performance targets are. It's harder when we hit storage account limits. We've got multiple virtual machines all accessing disks in that same storage account, and then randomly different ones start going slow because we're being throttled at a storage account level. We can be left scratching our heads a bit on this one because it can be a bit hard to diagnose. So to help us, we can enable alerting on our storage account to tell us when we get when we get throttled. It's not enabled by default. So we need to go into our storage account, and we need to turn on and add an alert for throttling errors. And we can alert, we can set a number essentially. So we say, hey, if we see more than 3 throttling errors in an hour, we want to be told about it. Personally, if I've got any throttling errors, I want to know about it. But it's about understanding what else is accessing that storage account. Because remember, I said storage accounts also have tables and queues. So I could be hitting that storage account with more than just virtual disks, more than just data disks. I could be hitting it from an application and hitting that queuing service, or hitting that table storage. That will all be adding to my IOPS that storage account is generating. So turn on those throttling alerts, and at least you'll start understanding if you're hitting those being throttled. And there's a really good article that you can read, which will can help you diagnose if you're getting that. Because sometimes just the way your application's architected, it can be hitting that storage too quickly, and you'll be throttled back. Right. So how do we go about reducing our performance requirements? We've talked about how we can, design for it. Well, this is where our temporary drive really comes into play. Okay, temporary storage is allocated from the disks physically attached to the hardware that our virtual machine is running on. Because of that, it means it's fast, it's really quick to access, low latency, and it's not going over the network, so it doesn't cost us any network traffic to use that temp storage. And as the chart shows, generally the bigger the virtual machine, the more temp storage we get access to, and as the size of the temp storage increases, our IOPS and our throughput to that storage increases as well. But we need to be really careful how we use temp storage, okay? Never place critical, unreplicated data on the temp drive, all right? There's even a big warning file that gets put into the temp drive in like 5 different languages saying, don't do this. There are a number of activities ranging from patching the underlying Hyper-V host, resizing your virtual machine, hardware failure, that will cause your temp drive to be wiped. It's called a temp drive for a reason. But it's really great for hosting things like SQL temp DBs, or if you've got an application that needs a scratch space or a read cache location. It's fantastic for that because it takes load away from your network and from storage. Now, Microsoft recommend using a startup script or a scheduled task to be able to configure your temp drive. All right? And a great way to confirm that that's working is to perform a resize operation on your virtual machine. When you resize your virtual machine, your temp drive allocation changes. So every time you do a resize, the temp drive gets erased and a new one gets created. So do that resize And that'll confirm that your script's working correctly and your application's being reconfigured to use that temp drive. Otherwise, you get woken up in the middle of the night because something's not working and you are moved to a different host. Okay, so look, we've spent quite a bit of time talking about sort of numbers and performance targets when it comes to Azure storage and compute. But this, sort of the main thing I want you to take away from the session is this. When you're architecting something in Azure, look at the different Azure services you're planning to use and understand the scaling options and know the service limits associated with those services. And if you do this, then you're going to be really well placed to select the right-sized offerings for your workload and to pull those services together in the most cost-effective manner. And you'll understand where a decision down here affects the cost of something up over here. Okay? Understand your scaling options and know your service limits. Hey, look, thank you so much for coming to the session this afternoon. Please do fill out your evaluation forms. I really do appreciate your feedback. And you go in the draw to win some really great prizes. I think we've got a couple of minutes, but I know some people might be keen to get a head start on the next session. So maybe those of you that have some questions, if you want to come forward, and I'll let everyone else kind of disappear if they want to. Or you can sit there and ask away questions if you want.